Okay, here's the last lesson for chapter 5. In this chapter, we've been looking at linear relations. This section, section 5.6, we're going to try and connect variation, slope, and first differences. So we're pretty much going to try and connect everything we've done throughout this chapter in this one lesson. I'm going to start off by looking at first differences. That's what we did in the last section, section 5.5. And what we want to do is we want to be able to classify a relation as either linear or nonlinear by using the method of calculating first differences and analyzing our results. So just a quick reminder of how we use first differences to classify a relation. We look at the y values in our table of values for the function. And what we want to do, we want to try and see, are these y values increasing at a constant rate? If they're increasing at a constant rate, that means this function is going to form a linear relation. If they're not increasing at a constant rate, it's going to be a non-linear type of relation. So there's an organized method for calculating these first differences to check if they're increasing at a constant rate. And what we want to do, we want to look at the first two y values in our table, -3 and 1. We want to see what is it increasing by when it goes from -3 to 1. In order to do that, find the difference between those two values by doing the second one minus the first one. So 1 minus -3. 1 minus -3, subtracting a negative means adding, so 1 plus 3 is 4. Now, look at the next two y values. See what it increases by for the next two. It goes from 1 to 5. Calculate the difference by doing 5 minus 1, the second one minus the first one, and that gives you 4 once again. Then check the next two y values. It goes from 5 to 9. Calculate that difference by doing the second one minus the first one. 9 minus 5 gives us 4 again. And then the last pair of y values, it goes from 9 to 13. Calculate the difference between those two by doing the second one minus the first one. 13 minus 9 is 4 once again. So you'll see the first differences are all constant. It increases by 4 each time. Because our first differences are constant, it's increasing at a constant rate, therefore it is a linear function. If when we calculate our first differences, we didn't get the same number each time, that would mean it's not increasing at a constant rate and it would have been a nonlinear function. Keep in mind, the only time you can use first differences to classify a relation is if the x values are evenly spaced as well. In this table of values, the x values go from 0 to 3 to 6 to 9 to 12. So those x values are evenly spaced. They go up by 3 each time. That's why we're allowed to use first differences to classify the relation. If the x values aren't evenly spaced, you can't use the table of values to do this method. Okay? Because we need to compare as x is increasing at a constant rate, what's happening to the y values? Are the y values also increasing at a constant rate? If they are, then it's a linear relation. If they're not, then it's a nonlinear relation. Okay, we also need to know how to use the table of values to calculate the constant of variation. So we've done a lot of work with the constant of variation throughout this chapter, and we've also talked about how when a relation is represented graphically, we call the constant of variation the slope of the line. Okay, the slope of the line is the constant of variation between the variables. So if you remember, we've used the formula to calculate our constant of variation. We used the variable m to represent the constant of variation. And we use the formula, the change in y divided by the change in x, and that will tell us what the constant of variation is. We're going to use a little bit more of an organized method to calculate the change in y and the change in x for this section of this lesson. Okay, so in order to calculate the change in y, remember this little triangle here, that means change in. So to calculate the change in the y values, we're going to use this formula here, y2 minus y1. Now this doesn't mean y times 2 minus y times 1 or y squared minus y to the 1. It doesn't mean that. y2 minus y1 means the second y value minus the first y value. Okay? So what we need to do to calculate the change in the y values, we need to pick two values in our table of values. It doesn't matter which two we choose. Just for to make it as simple as possible, I'm going to choose the first one and the second one. And I'm going to calculate the difference between those two by doing the second one minus the first one. So I'll label these. This is my first y value, I'll call that y1. This is my second y value, I'll call that y2. And in order to, later on I'm going to need the x values as well. So I'm going to have to pick the corresponding x values as well. So this, if -3 was my y1, that would mean that 0 is my x1. If 1 was my y2, that means 3 is my x2. So I've got my first x value, my second x value, my first y value, my second y value. I'm going to plug that into my formula y2 minus y1 divided by x2 minus x1, and that is my change in y divided by change in x, and that's going to give me my constant of variation, or my slope, my m value. So let's do that. Let's plug these values into our formula. So slope equals y2 minus y1 divided by x2 minus x1. Well, y2 is a value of 1, so I'm going to plug that in. So 1 minus my y1 value, which is negative 3, plug that in, negative 3, divided by my change in x, so my x2 minus my x1, 3 minus 0. And let's simplify this. 1 minus negative 3 is 4, 3 minus 0 is 3. There's my constant of variation, 4 over 3. So, next part, what is the initial value in this table of values? When it says initial value, what that means, it means when x equals 0, what does y equal? What does y equal? So in this case, our table of values, we're going to look at our table of values, and you'll actually be able to see, let me just get rid of this stuff, you're actually able to see there's a value of 0 for x in our table of values. And therefore, we can easily calculate, or we can easily see what our initial value for y is. So when x is 0, what's y? Y is negative 3 when x is 0. Okay, so that's our initial value. And the initial value, we know we used the variable b for the initial value. The initial value is negative 3. Next part of this, is this a direct or partial variation? Well, hopefully you remembered that a direct variation has an initial value of 0, while a partial variation has an initial value that is not 0. So the initial value in this case is negative 3, therefore it is a partial variation, because negative 3 is clearly not 0. So this is a partial variation. The next part of the question wants us to write an equation in the form y equals mx plus b. We can go ahead and do that because we know our m and b values. All we have to do is plug those into our equation. Our m value was 4 over 3, and our b value was negative 3. Plug those into y equals mx plus b for m and b, and we get y equals 4/3 x minus 3. And that's the equation for the relation. If we want to graph this relation, all we have to do is plot our initial value. So we know it starts at negative 3. So it starts at negative 3 on the y-axis. And then use our slope, or our constant of variation, to plot more points and connect them with a straight line. So we know our slope. Our slope was 4 over 3. And we know that slope is rise over run. So if our rise is 4, that means we have to go up 4. 1, 2, 3, 4. And then our run was 3, so that means go to the right 3. 1, 2, 3. And plot a point. And then use the slope to keep plotting points so that we can form a line. So up 4 again from our new point, and then right 3. 1, 2, 3, 4. 1, 2, 3. Keep going. 1, 2, 3, 4. 1, 2, 3. Keep going. 1, 2, 3, 4. 1, 2, 3. And that's good. I'll just connect these with a straight line. And that's roughly what the graph of this line looks like. Now, part G says find the slope of the line from the graph. How does this relate to the constant of variation? Well, so to calculate the slope of a line from the graph, choose any two lattice points on the line. So I'm going to choose this one, and then count your rise and your run. So to get from that first one to the second one, I have to go up 1, 2, 3, 4. I have to go up 4, and then I have to go right 1, 2, 3. So going up 4 means my rise is equal to 4. Going right 3 means my run is equal to 3. And then I know my slope equals rise over run. So my slope is 4 over 3. So hopefully you noticed that the slope we calculated using the graph, is exactly the same as the constant of variation we calculated using our table of values back in part B of the question. Okay, so the slope is the same as the constant of variation. Now, next part, what is the y-intercept? How does this relate to the initial value? So look at your graph. Where does the graph cross the y-axis? It crosses the y-axis right here at 0, -3. Okay, so what is the y-intercept? How does this relate to the initial value? Well, the y-intercept is the initial value. The initial value of our table of values is -3. The y-intercept of our graph is at -3, so they are the same. Let's write an equation of line form equals in the form y equals mx plus b using the slope and the y-intercept. Well, our slope is our m value, which was 4/3. Our y-intercept is our b value, which is -3. Plug those into y equals mx plus b, and we get y equals 4/3 x minus 3 once again. So this is just to help you make the connection that the initial value is the y-intercept when the relation is represented graphically, and the constant of variation is the slope when it's represented graphically. Okay, so throughout this chapter, we're going to be working with, or throughout this lesson, sorry, we're going to be working with the rule of 4. So a relation can be represented in a variety of ways, so it can be looked at from different points of view. So a mathematical relation can be described in 4 ways. We can describe it using words, using a graph, using a table of values, and using an equation. So we're going to start off by writing an equation when the relation is represented in words. So remember that an equation of a line is y equals mx plus b, where m is your constant of variation, b is your initial value. Considering that the line is, so when you have a line, if this is my graph, here's my line, this line is really just a set of ordered pairs. So I've got points all over this line. I don't know if we'll be able to start a new one. So a line is just really a bunch of points. Okay, it's just a set of ordered pairs. So this is my line. It's just got a bunch of points on that line. So it makes sense that the equation of a line needs to contain the variables x and y, because a line is just really a set of ordered pairs that are connected, and ordered pairs have an x and a y coordinate. So we need x and y in the equation of a line, and these variables will define the coordinates that make up the line. So if x and y represent all of the points on the line, the only other 2 variables left are m and b. So those are the variables you need to determine in order to write the equation of the line. When a linear relation is represented in words, we often call m our rate of change, okay? And we call b our initial value. So when we're talking about word problems, usually m will be your rate of change, or sometimes it'll be called your variable cost. And b is going to be your initial value, or sometimes your fixed cost when we're talking about money. Okay? And let's do this example here. Write an equation for the following relationship by first identifying the values of m and b. So we need to read the sentence here. The copy center charges $75 to design a poster, plus 25 cents for each copy. So we need to think, first of all, which one of these is our rate of change, or our variable cost, and we need to think which one of these is our initial value, or our fixed cost. So they charge $75 to design the poster. So that's your fixed cost. And then they charge 25 cents for each copy. Okay, 25 cents per copy, that's your variable cost, or your rate of change. So m is the variable cost, so that's our 0.25, 25 cents. And our b value, our fixed cost, or our initial value, is the $75 they charge you to design it. Therefore, the equation, we know the equation is y equals mx plus b, so it's y equals 0.25x plus 75. And this makes sense. The cost the copy center will charge you is equal to 25 cents times the number of copies plus the $75 design fee. If the copy center changed their cost per flyer to 35 cents for each copy, so if they changed their variable cost, their m value, to 35, the new equation would be 0.35x plus that $75 design fee. If they changed their design fee to $125, the equation would be, let's assume that the variable cost is still 0.25, 25 cents times the number of copies, plus the initial value, or fixed cost, b, would now become 125. That would be the new equation. Next example, it says y varies directly with x, and then also when x equals 2, y equals 8. So it's really important to notice that it says y varies directly with x, because that means the initial value is 0. The initial value is 0. And that's true for all direct variations. The initial value is 0 because we know the line is going to pass through the origin at 0, 0. To calculate the slope of the line, we're going to need 2 points on the line. Well, we know it crosses through the origin. So the first point will be 0, 0, because we know it goes through the origin because we know the initial value is 0. And the other point, the second point that we have, I'll call that point 2, it tells us when x is 2, y is 8. Okay? So this was point 1, and point 1 was 0, 0, point 2 is 2, 8. Now I want to calculate the slope. Remember back to the beginning of this lesson, we know to calculate the slope we have to do change in y, so the second y coordinate minus the first y coordinate, divided by the change in x, so the second x coordinate minus the first x coordinate. So I've got point 1, so that would be my first x coordinate and my first y coordinate, and point 2 would be my second x coordinate and my second y coordinate. Let's plug those into our formula. We'll figure out the slope equals the second y minus the first y, so 8 minus 0, divided by the second x minus the first x, 2 minus 0. And that will give us 8 over 2. I'll continue this up here. 8 divided by 2 is 4, so my slope is 4. If I want to write an equation, I know it's y equals mx plus b, so y equals 4x, so my m value is 4, plus my b value is 0, plus 0. Now there's no point in including that plus 0, so I don't need to include that in the equation. Adding 0 doesn't do anything. I can take that out, and there's my equation of the line. And because this is a direct variation, it looks exactly like what the equation we know for all direct variations. All direct variations look like y equals mx. We don't need the plus b because for a direct variation the b value is always 0. Example 3, y varies partially with x. So in this case it tells us it varies partially. So that means that it is a straight line, but its initial value is not 0. It also tells us when x is 0, y is 3, when x is 2, y is 8. So what's our initial value? Initial value means when x is 0, what does y equal? And we know in this case, it tells us right in the question, when x is 0, y equals 3. So our initial value, our b value, is equal to 3. What is the slope of the line? Well, we need our 2 points. Point 1, which is 0, 3. And we need our second point, point 2, which it tells us when x is 2, y is 8, so that's our second point. Now label these points. Our first point is going to be our first x coordinate and our first y coordinate. The second point is going to be our second x coordinate and our second y coordinate. Remember, every point has an x and a y coordinate. So our first point is x1, y1. Our second point is x2, y2. Now we're going to use our formula for slope. Slope is y2 minus y1, our change in y values, divided by x2 minus x1, our change in x values. Plug everything into the formula. I get 8 minus 3 over 2 minus 0, which is equal to 5 over 2. So now I have my b value, I have my m value. That's all I need to write the equation of the line. I know the equation of a partial variation is y equals mx plus b. I need the plus b because my b value is not 0 for a partial variation. Plug in my m and b values. I get y equals 5 over 2x plus my initial value was 3. Good, and remember, whenever you write the final equation of a line, you don't plug in for y and x because the final equation stands for all of the coordinates that make up the line. Okay, so we only plug in for m and b. That's what defines the line. Part 4, write an equation when the relation is represented in a table of values. So if I'm given a table of values for a relationship, I want to first be able to calculate the rate of change, or what we call the slope when it's represented graphically, and I'm also going to need the b value, the initial value. So that means what's the value of y when x is 0. and we know that that will be on the graph, that'll be the y-intercept of the graph. So let's look at our table of values. Determine the equation of the following linear relations using the tables provided. So I've got my first table of values here. First thing I want to do is I'm going to calculate my slope. So to calculate my slope, I know I need to find the change in the y values, so I'm going to do the second y coordinate minus the first y coordinate divided by the change in the x values, my second x coordinate minus my first x coordinate. So I need to pick the 2 points I'm going to use to calculate the slope. Any 2 points will do. Once again, I'm just going to choose the first 2 points to make it as easy as possible. So I'm going to choose this first point here. That's going to be my first point, so I'm going to label that this is my first x coordinate and my first y coordinate. And then the next point, I'm going to choose the point right beneath it, so that's going to be my second x coordinate and my second y coordinate. So my x1, y1 is 0, 6, my x2, y2 is 1, 9. Plug that into the formula. So second y coordinate minus first y coordinate is 9 minus 6. Second x coordinate minus first x coordinate is 1 minus 0. I get 3 over 1, which I know 3 divided by 1 is equal to 3. So the slope of this line, or the rate of change between the variables, is 3. B, I know, is my initial value, so when x is 0, what does y equal? Well, if I look at my table of values, when x is 0, y equals 6. Therefore, my initial value is 6. So I can write the equation of my line now that I have m and b. That's what defines my line. Plug that into y equals mx plus b. My m value was 3, so y equals 3x, plus my b value was 6. So y equals 3x plus 6 is the equation of that line. Let's do the next one. For the next one, same thing. I'm going to start by calculating my slope, which I know I have to find the change in the y coordinates. So my second y coordinate minus my first y coordinate divided by the change in my x coordinates. Now what I have to do is choose 2 points. For this one, I won't choose the first 2. I'll choose a different 2. I'll choose the first one and the last one. Why not? You can choose any 2, and you'll get the same constant of variation. So here's my first coordinate. So this is my x1 and my y1. And I'll choose the last point as my second x coordinate and my second y coordinate. Plug in the information into your equation for calculating the rate of change, or your slope, and I get 11 minus 3 over 6 minus negative 2. Doing this, I get 8 over 8, which I know 8 divided by 8 is equal to 1. My initial value, so be careful with this one, the initial value isn't always the value at the top of the table of values. The initial value is the value of y when x equals 0. So when x equals 0, the value of y is 5. So my initial value is 5. So to write the equation, I have my slope, I have my y-intercept, or I have my rate of change and my initial value. I can write my equation by plugging in my m and b values. My m value is 1, so y equals 1x, plus my initial value of 5. There's the equation of that line. Okay, so what should we do if the initial value isn't in the table? Well, first thing we're going to want to do is we're going to want to calculate our slope. Calculate our slope by doing change in y, y2 minus y1, divided by change in x, x2 minus x1. Pick 2 points in your table of values. I'll just choose the first 2 I have to be my x1, y1, and my x2, y2. Plug everything we know into our formula, and I get negative 8 minus negative 11 divided by 3 minus 2. And I figure out negative 8 minus negative 11, that means negative 8 plus 11, which is 3. 3 minus 2 is 1. 3 divided by 1 is 3. So that means my constant of variation is 3. That means that this function, this linear relation, is increasing by 3 every time as x is increasing by 1. So now if I want to find my initial value, I need to figure out what does y equal when x equals 0. Well, I don't have a value of 0 for x in my table of values, so I'm going to have to continue my table of values to get an x value of 0. So look at the x values. If we start at 4, it's decreasing by 1 at each time. It goes from 4 to 3 to 2. So the next one would be 1, and the value after that would be 0. So now I need to figure out the corresponding y value that goes with the x value of 0. Before I do that, I'll figure out what goes with, when x equals 1, what does y equal. So let's look at the y values. So I know as x increases by 1, I know y is going to increase by 3. That's my constant of variation means. So if when x increases by 1, y goes up by 3. If x decreases by 1, y is going to go down by 3. So if when x is 2, y equals negative 11. When x goes down by 1 to 1, y is going to go down by 3 to negative 14. Then when x goes to 0, goes down another 1, y is going to go down by another 3. It's going to be at negative 17. So my initial value when x is 0, y is equal to negative 17. So my b value is negative 17. Therefore my equation is y equals mx plus b. So y equals 3x minus 17 is the equation of this line. Next one. So let's look at our table of values once again here. Our slope, we'll calculate our slope first by once again using our formula, change in y divided by change in x. Pick 2 points, I'll choose the first 2. Here's my first x coordinate, my first y coordinate. Here's my second x coordinate, my second y coordinate. Plug those into the formula. I get negative 10 minus negative 5 all over negative 6 minus negative 8. Okay, so let's simplify this. Negative 10 minus negative 5. So that means negative 10 plus 5. That is equal to negative 5. Negative 6 plus 8 gives me a value of 2. So that means that as x is increasing by 1, y is actually going to be going down by 2.5, or negative 5 over 2. Okay? So in order to complete this table of values, we're going to look at the trend in the x values. It starts at negative 8, and then it's increasing by 2 each time. So it goes from negative 8 to negative 6 to negative 4. The next value would be negative 2. The next value after that would be 0. Increases by 2 each time. Then look at the y values. The y values start at negative 5. Then it goes down by 5 for the next one. It goes to negative 10. Then it goes down by 5 again. Goes to negative 15. And the pattern is going to continue. It's going to then go negative 20, negative 25. Okay, and let's think about the reason behind why this is happening. So keep in mind, our constant of variation equals negative 5 over 2, which as a decimal is negative 2.5. So what this means is, this value here, this means as x increases by 1, y is going to go down by 2.5. Okay, so if it goes every time x increases by 1, y goes down by 2.5. That means as x increases by 2, y is going to go up by double this 2.5, or go down by double 2.5, which is 5. So as x increases by 2, y should go down by 5. And look at our table of values. That's exactly what's happening. As x increases by 2, so it goes from negative 4 to negative 2, y should be going down by double our constant of variation. So double 2.5 is 5. It goes down by 5. It goes from negative 15 to negative 20. So that's exactly what's happening. That's why you see this pattern in our table of values. So our initial value is the value of y when x equals 0. So here's when x equals 0. The value of y is negative 25 when x equals 0. So our initial value, our y-intercept, is negative 25. So our equation is y equals mx plus b. So y equals negative 5 over 2 x minus 25. Next part, write an equation when the relation is represented as a graph. Okay. So if we're given a graph of a line, we're not going to call it a rate of change or a constant of variation for these. We're going to call it our slope, and we're going to calculate our slope, our m value, using the formula rise divided by run. Rise is our change in our y values, and run is our change in our x values. That's why the slope is the same as the constant of variation or the rate of change. And our b value, we're going to call our y-intercept. Okay? The initial value is going to be where the line crosses the y-axis. That's why we call it the y-intercept. So the graph shows the relationship between the volume of gasoline remaining in a car's fuel tank and the distance driven. So let's calculate our slope. I know slope equals rise over run. So to calculate my slope, I have to choose any 2 points on my line. I'll just choose these two right here, the first 2 points I see, and I'm going to calculate my rise and run between those 2 points. So my rise, to get from the first point to the second point, I have to go down 13 units. I have to pay attention to my scale on my graph. I have to go down 13. So now that gives me a negative rise, so negative 13. And then I have to go to the right 100 units. Pay attention to your scale. It's going by 100s each time, so I have to go right 100. And there's the slope of my graph, negative 13 over 100. I know going down gives me a negative rise, going right gives me a positive run. Therefore, the overall value of my slope is negative. I have negative 13 divided by 100. That has an overall negative value, and any line that goes down to the right is going to have a negative slope. So that makes sense. The y-intercept, where does this graph cross the y-axis? It crosses the y-axis, crosses the y-axis right here at 65. So my y-intercept, my b value, is 65. Therefore, the equation of my line is y equals negative 13 over 100 plus my initial value, my y-intercept of 65. And that's it. Hopefully we've connected everything we've done this chapter. Let me know if you have any questions. Make sure you get the worksheet from jensenmath.ca and try it out. Let me know if you have any questions.